Hey everybody, this is Larry, this is me going Q2 of the bi-weekly contest 133. Minimum operations to make binary array elements equal to 1, 1, 1, 1. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about this one. So this one, the key part of noticing is that if you go from left to right, or in one direction really, is that everything is forced, right? It's not quite greedy, but it is forced. And what I mean by forced is that there are no decisions, right? And what I mean by no decision is that when you go from left to right, so let's say you're at this cell, right? If you're at this cell and it's 0, then you have to flip it to 1. Because if you don't flip it to 1, you can't go to the left of it or something and then flip it to make this a 1, right? So okay, so then this is a 1, then this is 0, oh, and this is 0, right? So then, okay, let me just actually ask you, why is this in Java? I know why it is in Java, but spoiler alert. But yeah, so let's say you have something like this, right? After flipping the first one, it's gonna be this. And here, now that you know the left is done, you could effectively treat it as chopped off, right? So you could chop it off, so it looks like this. But then now, you have to, now that you see a 0 here, you have to flip this because you don't, if you flipped it before, you know that doesn't work by a sort of an induction kind of mindset. It's not quite an induction, but yeah, so you have to flip this. So then now this is 1, this is 1, this is 0, right? And so forth. So in that way, you don't, if you think about it in that way, there is no decision, right? You have to do it every step of the way. And that's basically the idea behind this problem. Yeah, my solution. So yeah, so I just go for I is equal to, every time we say 0, we flip the next 3 numbers, including this one, and then we count the number of flips. If they're all 1s, then we can return count, otherwise it's -1. And this is just a little bit lazy, to be honest, because I think it's sufficient to check the last 2 elements, right? Because those are the 2 elements that you have no choice, because you have 2 elements left, you cannot choose the next 3 elements, right? And if they're still 1s, then you're good. This is going to be linear time. This is linear time, linear space, because we do modify the input array. I consider that extra space because you shouldn't modify the input in general. But you can do this in constant time by just like keeping track of, yeah, just keep it like in the same way that you would do it in Fibonacci, right? You just keep track of the 2 numbers ahead of you, and that should be good enough to get it in constant time. But of course, it's just a little bit more keeping track of things, and very obviously easier to make mistakes. And for me, I've been making a lot of mistakes, so yeah. Anyway, that's all I have for this one. This is linear time, linear space, and yeah, you can watch me solve it live during the contest next. Alright, let's take a look at the other one. Oh, there we go. It's accepted. Alright, let's now take a look. Actually, is this the same? No, it's different problems. So okay, so I have to take a look. Okay, for all of them. Okay. Maybe this should be a folder. What? Did I misunderstand this one? Oh, you go to 1. Whoops. Well, I guess I only have to change this and this. I totally misread that one. 3, -1. All right. Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem, this explanation, everything in between. Stay good, stay healthy, to your mental health. I'll see y'all later and take care. Bye-bye.